Hi, my name is Johnson. This is a project I designed for the ESCOM Expo, which is a youth science fair. And this project took me all the way to the International Science and Engineering Fair. And basically, it's a low-cost prosthetic hand, but at the same time, really functional. Because it's very close to that of a human hand, and it's scaled, as you can see. And it costs a mere 1,900 Rand. It's still a prototype, so I've got a large margin where I can spend money to develop it and stuff without it being too expensive. Where I see it going is I'd like to get it a lot better, and I'd like to get it to be something that does something really groundbreaking, you know, that makes a real difference in a community. So instead of it being bilateral hand function, I'd like it to be able to do the really fine motor skills. So maybe collaborate with another company while keeping the cost down.
My name is Korimer. I'm from the University of KwaZulu-Natal, and we are here to demonstrate our invention, the Powerline Inspection Robot. This robot is designed in order to roll along power lines, doing inspections and sending visual data back to the ground for an inspector to check for faults on the power line. So the idea behind the project is to save ESCOM money by preventing them from needing to send helicopters up to do the inspections. This saves on a lot of fuel costs. It also is a lot safer than sending people up by a helicopter to inspect the power line. Our first prototype is over here, and our second prototype is here. This is a pre-production prototype, so we are almost ready to go onto a power line. In terms of the physical hardware, it's about 100,000 Rand. In terms of the human effort and time, a little bit more.
My name is Csir from the CSIR. We have developed this inspection vehicle in collaboration with ESCOM, and our other partners is Aerial Concepts and also Tower 35. The idea behind this vehicle is to fly along the power lines and inspect faults. Should it find any faults, it will be recorded and transmitted to a control station. A report will be written, and whoever needs to come and repair it will repair it. Currently it's a prototype unit, so it is pilot controlled and another individual controlled. Ultimately it will be an autonomous flying system, so it will fly approximately for 1 hour along the line, around 5 kilometers, go to the other side and return also the 5 kilometers. Whatever is recorded with regards to faults will be recorded, and a report will be generated also automatically at the control station. The idea is that it will replace normal conventional inspections by helicopter, as it's a tremendous cost saving of approximately 10% of conventional flight inspection. The system comprises of a normal aspirated fuel engine that's used in model aircraft. Underneath is a gimbal that is controlled left, right, up and down. It's stabilized, so whatever happens to the helicopter in the air will be stabilized by the gimbal. And it also consists of a camera, multispectral camera, with a thermal, visual and UV channel. And that's where the heart of the matter is in the UV channel that detects the corona from any faults of the lines. It's overlaid onto the visual, so once the corona is off, one can actually see the fault on insulator or on a stranded component. And the thermal is just to pick up any preventative maintenance that need to be done without a fault that would occur and be seen on with the corona.